Hey guys, Ray here, welcome to the channel. So today we are looking at this battery from VNice. So after editing this video, I was having problems getting this battery to work. So this video is really mainly about testing battery cells and the solid state cells that this battery claims to be offering. So they are claiming to be the first to create a solid state LFP rack battery. I'm curious to open this up, look at the cells. They say they are very safe. We're going to test the safety of these cells. And holy crap! We're going to see how much this battery weighs versus a traditional server rack battery. I'm curious to see what kind of feedback you guys have in the comments. When I said this is a solid state battery, that's what they are claiming. The word solid state has kind of been used as a buzzword to get extra funding. I know there's been recently a power station company that claims they have a solid state power stations. And there's been some studies and they found liquid in the battery cells. So I don't really want to go into that too much. Matt Farrell has a good YouTube video on that whole power station. I'll put a link to that in the description. But anyways, whenever someone claims they have a solid state battery, I would take it with a grain of salt. Electric vehicles are doing really well right now, but supposedly once solid state batteries come out, they're claiming instead of getting the traditional 250 miles per charge, with a solid state battery, you can get magically 650 miles per charge. There recently was a company in China that designed their car for solid state batteries, and the car came out and it's using the traditional battery instead of the solid state batteries. So who knows if they're going to come out at all. So this is a traditional lithium iron phosphate battery, or LFP battery. I did a video on installing this to run my entire house electrical panel. They put these in houses because they are considered very safe. So these are not to be confused with the lithium chemistry that's in laptop batteries or e-bikes. This is the wall mount version, and this is the server rack version that can be stacked. But before we open this up and look at the cells, let's go ahead and see how much this battery weighs compared to my traditional server rack battery. Now both these batteries are going to have about the same capacity. I'm going to be measuring my LifePower 4 EG4 server rack battery, and it has this same 100 amp hours and this roughly the same voltage. So these should have the exact same capacity. Okay, here's the LifePower 4 battery. 108 pounds, okay? These are supposed to be half the weight, right? 97 pounds. So I asked the company about why these batteries are so heavy. They didn't answer me specifically, but they said in response, we pay more attention to safety performance. So we're going to look at the safety of these batteries. Before we look at that, let's open the battery up and look inside. So the build quality actually looks pretty good. Quick connect ports. We have got a screen, breaker, some handles here. All Allen keys. I cannot find my other glove for some reason. Here we go. Wow. Dang. Well, that is a lot of pouch cells. This is like glue or something. So yeah, it looks like there's a bunch of bus bars that connect all these cell ends. And see, this is negative. It goes through this breaker here. And that's positive. So that's negative, even though that's red. So guys, I cannot turn this on. I don't know. So apparently that's the on switch, the on breaker, but I'm not getting any voltage here. This screen is not turning on. 52.7 volts, so there should be voltage. So this has been sitting in my garage for like over 6 months. I don't think I damaged this unit, but maybe something fell on it. So one thing I wanted to test with these cells is if they're damaged, will they cause a fire? Say there's an earthquake and the battery cell gets punctured, is that going to have a reaction? Is it going to start a fire? Or if you're doing construction and you accidentally drill a hole through the wall and it punctures the cell, is that going to start a fire? So I had a hard time pulling these cells out of the battery, but they did send me some sample cells of a few different types, And I think they're the same cells that are in the battery. I'm not totally sure, but I test all the cells that they sent me, including the cells in the battery. Okay, so I told them that I wanted to drill some holes in these cells and see what the reaction was. So they sent me a few different samples of cells, and this is a LFP, lithium iron phosphate, traditional cell, and I bought this online. So I'm gonna drill a hole through this one, this cell I have here I bought. So I'll be honest with you, I was not able to find the exact chemistry of these cells. I'm not sure that I can believe what the company said about these cells, but I'm just gonna test them. I will include the sticker of the cell. Maybe you guys in the comments can find any more information, but I wasn't able to find anything. Okay, let's drill through these. We'll just go top to bottom here, but let's do this one first. Okay, this is supposed to be one of the more dangerous pouch cells, and I was kind of disappointed because nothing really happened. Okay, so this is going to take a while, I can tell, so I'm going to just drill a few more holes in here. It's just barely warm. Here we go. That was smoking. About 300 degrees Fahrenheit right now. Stop smoking though. Well, I thought I was going to get a big ball of flames, but just curious, let's just try a whole bunch of screws on this side and see if we get some flames. Let's try this cell. Here's some information about it if you want to look it up. I couldn't get that QR code to scan. I got a little smoke. Nothing. A few sparks. There we go. Whew. It's very boring. I thought we'd be seeing some flames, man. Okay, let's try these cells. I believe these are the same cells that are in this battery pack. So if these go up in flames, that would be really bad. Well, there is no smoke out of this one. There's a little bit of smoke right there. Well, if these are the cells that are in that battery pack, I think these are definitely safer because there's nothing. All right, let's try these. I don't want the two ends to touch because I'm not sure which is positive, which was negative. Whoa! Yeah, those have a charge. Huh. Woo! Okay, that's kind of cool. All right, let's try drilling a hole through both of these. I don't want to discharge the battery fully because that would kind of negate my test here. Tiny bit of smoke there. Yeah, no flames at all, just smoke. And hardly any smoke. Okay guys, so I was really trying to get this to smoke and flame up, but if something happens to my batteries in my house and that's all that happens, just a little bit of smoke, that sounds great to me. So let's do this traditional LFP or lithium iron phosphate cell. This is This is the type of cell that would go in your server rack batteries, but granted, this is the cheapest cell I could find online. Should not be compared with the EG4 batteries or other types of batteries. It looks like a traditional cell that would go in that type of battery, but let's try it out. Okay. I'm just gotta leave that for a second. Holy crap. No flames. Okay, so I was just looking this battery up online. So they're now calling this a semi-solid state LFP battery. So changing the marketing a little bit. So yeah, I wonder if these pouch cells are the same type of pouch cells that are in these mini batteries. This lithium iron phosphate battery has little pouch cells. I wonder if they're exactly the same. So anyways, this battery is not working because I probably broke it when I was moving it around, kind of fragile. I also noticed that, look at this. It's like a 8mm bolt or something, super small. Surprised they have that small bolt on there. I'm not sure what to do with this battery. I don't want to give it away because I don't even know what the chemistry is of this battery. It'd be nice if they just called it a LFP battery and then people would know exactly what they're getting. But anyways, I'm gonna drive a rebar right through the side of these. And you know, let's have a little bit more fun here. I'm not getting any power out of these lugs here, but I'm just gonna bypass the BMS here that's preventing power from coming out. And let's do a short circuit, see what happens. Yeah, just 52 volts, so there shouldn't be a lot of arcing, but there should be a ton of current. And I'm gonna put my multimeter right here, and we'll see how much current we can get through this battery. Okay, so I've got my terminal disconnected. I hooked it up to this plastic, and then I can move it down here and touch that end. Between these two ends, there's 52.7 volts, but I'm not sure what kind of sparks I'm gonna get, so I actually went up and bought a face shield. Test. All right, here we go. Try it out here. This is gonna be interesting. Holy crap. Oh, I forgot to put my multimeter on there. Okay, this multimeter has a max min button for current, so it should be able to catch the maximum amount of current that is going through. The thing that most surprised me is after I did this, the front screen started working. I have no idea why. It shows my battery at 51.7%, and there's the voltage of the battery pack. Wow. Yeah, the breaker was turning on and off, but it wouldn't affect the screen. This was kind of freaking me out, so... There we go. Wow, that's crazy. Try this again. Okay, that was fun. All right, let's drive this through the side. I couldn't find my rebar, but this might be easier. This is just I think it's galvanized nail. Oh yeah. Woo! That's getting more of a reaction. Holy crap! Oh, oh man! Oh crap! Woo! Holy cow! That was a war zone. That was kind of scary. Holy cow! It was the tape breaking. Yeah, the way these cells are reacting, I'm not sure they are the exact same cells that they sent me to test. These seem different. So I tried pulling out these cells later, but they are just glued in there. I tried prying them off, but I just couldn't get the cells out. Okay, I wish we could have seen how much amps we were pulling through that, but couldn't. And looks like there's some fluid that was dripping. I'm not sure what that is. I'm not going to touch it. But wow, it's crazy. Oh yeah, let's look at this. I didn't see any flames. I really tried to get this to start on fire, but I couldn't. So last year at Lake Powell, there was a houseboat fire, and they actually blamed the fire on the lithium batteries. So I don't think that was the case. I think it was probably the wiring of the batteries. They probably didn't have fuses on there. They were probably using too small of wire. But I tried to start a fire with these batteries, and I couldn't do it. The only way I was able to see a flame was when I bypassed the BMS, bypassed the safety feature of the battery, short-circuited the battery, and then I got a fire when the wire insulation started to burn. Now, many of the batteries, like the ones I have here, traditional LFP batteries, they have certifications and they're put through very rigid testing. According to my understanding, they're burning the batteries, seeing how it will react if there's a house fire. Now, contrast that with maybe my vehicle here. This has 15 to 20 gallons of gasoline in there. Let me know what you think I should do with the rest of these cells, if I should do any more experiments in the comments below. I've got a lot of these that are undamaged. But we'll catch you guys on the next one. Thanks a lot. See ya.